So this is purposely a workshop and not a lecture. So I really, really want you to ask questions. I'm sure I've got lots of different backgrounds here, even though it's aimed at testers. Just a quick hands up, who is actually a tester? And then do I have any devs? Yeah, that's cool, interesting. PMs, anything else? BAs? No? Okay, cool, that's awesome. After this workshop, if you do want to go and have a look at the code, it's all on GitHub. If it doesn't make any sense, then you just pop me a message and I'll help you out, because the whole point of this is that you get some insight into what us devs are doing. So I really, really want it to make sense to you, so you're more than welcome to give me a shout afterwards. Like, even if it's 5 years down the line and you've only just got to it because you had a really long to-do list, it's totally fine. Okay. So I'm going to start. So welcome to TDD For Testers. Obligatory Twitter things. Please do have a tweet about things. My name is Sarah. I am currently living in London, but I'm actually from sunny Johannesburg. This weather is wonderful for me. I've been working as a dev for about 7 years, and my philosophy is that software product development is a team sport. Whether you are a dev, a tester, a BA, product owner, if something needs to be done to get your product out the door, you should be getting on board and getting that out. So I've got 2 main points of today. Is I want you to get an insight into what TDD means as from developers and how we use it. And the other thing is what a QA will bring to TDD and why TDD is not going to erase the QA role. So we'll be doing a little bit of theory, and then we'll be looking at some code, and we'll be chatting about a couple of insights afterwards. So test-driven development was rediscovered by Kent Beck. He says rediscovered because when people started writing programs, they would write what they want their output to be, and then they would write their program. It seems pretty logical, but somewhere along the line we lost this. And generally, as a modern programmer, what we would do is we would have written our logic, and if you're lucky, we would have written some tests, and then we would have most definitely refactored things. The idea is really simple. All you do is you flip around your test and your logic writing. You might have heard of a technique called Green Refactor. So the idea is that you write a test in code, you see your test fail, it goes red, and you write the minimum logic to make your test pass. You see your test pass, it goes green, red, green, and then you can refactor. You're allowed to refactor after that because now you're in the safe zone. Okay, but we're talking to testers, so what kinds of tests are we actually talking about? As a dev, I would mostly write unit and integration level tests, and these would always be automated tests. So I call this developer TDD, it's usually just called TDD. And then you get something called acceptance test-driven development. It can be automated, which is really difficult, or it can be, it's generally manual. Simply the idea is that you come up with acceptance criteria at a story level, and that would filter down into becoming integration and unit tests. What are integration and unit tests? So essentially a unit test is testing either a function in a class, so a class is one set of functions, if you want to call it that, or it could be testing a whole class. An integration test is when you start going beyond that level and integrating with maybe a database or a real-life file or that kind of thing. Obviously, an acceptance test, hopefully you're writing user stories, but if you're not, you might see it as a use case. It is something that will clarify whether you have passed business requirements or not. Usually these are written by people who are not developers, but hopefully these days the dev is getting involved. I wanted to clarify about end-to-end tests and functional versus non-functional. So some of the more old school testers talk to me a lot about functional and non-functional testing. you get functional and non-functional testing across any layer, right? So functional being more related to the business requirement, non-functional being more related to the operations of your system. Is it going to fall over? Is it going to be okay? And end-to-end tests, in my mind, are not necessarily acceptance tests. So I like to make a distinction between an acceptance test and an end-to-end test. End-to-end tests specifically go from the bottom of your code to front end, and hopefully through multiple layers. So if you're hitting other APIs or databases and things like that, that'll be an end-to-end test. An acceptance test specifically needs to match acceptance criteria. An acceptance test may or may not be an end-to-end test, and we'll have a look at that. In terms of where we are in the pipeline, so you'll have your source control, and then something will build, and then you'll run automated unit and integration tests. Those are the ones we're going to look at today. You'll write some automated acceptance tests, and then you'll deploy to certain environments. Usually, if you are more of a manual tester, your environment is the manual user acceptance testing environment. So you might run some manual regression testing and that sort of thing in that environment. And systems integration testing is so that you can test against other systems that you might be reliant on. Any questions so far? Have I lost everybody? Is it making sense? Yes. Okay. So I like to define these things and put it in context just so that it's clear, because I've met a lot of testers, and some of them are like automated pros, and some of them are still using that horrendous HP software, and I pray for them. Okay, so cool. That was quick and easy. We're going to look at some code. So you can tell I'm a dev, because I'm happy now, now that we're actually doing some code. Okay, so if you go and look at this afterwards, I've done this very specifically because it's meant for people who don't necessarily code all the time. So you will find that there are some pieces already done, and part 2 is essentially a section of completed work. So if you are doing this on your own and you get a bit stuck, you can have a look at part 2 and see what's working there, or you can give me a shout. All right. So if we have a look at this, don't actually know how to make it any bigger. So a dev will often do something called a kata, which is basically a practice that we do to practice TDD. And we often get requirements that look like this. This is acceptance criteria to a dev. Okay. So what you do is you take a rule and you try and implement the rule. And that's as simple as that. Okay. So if we have a look, so what we've got here is our first rule is that we always want to, okay, so actually I should tell you what we're doing. This is just a credit rating algorithm that I completely made up and is not real. So the first rule is that you want to return at least a minimum of 0. Okay. If you do have a question, just shout, because I can't really see you. Alrighty, so how do we do this? We know, so we've got this thing called a service, and this service is going to house our algorithm. Yeah? Okay. And what we want to do is we want to ask the service, when I test the credit rating, if I give you an occupation, that you at least return something bigger than 0. Okay. So this test is already a regression test because you can run it every time. So let's just have a look at the code. So actually, let's run the test. So if we run our test, test running service, blah, blah, it'll come back and tell us that our test has passed. Okay. How does the test pass? Because I've written some code for it to pass. And this is all we've got as our algorithm right now. So in Python, you always have to pass an instance of self. Don't worry too much about that. and then we've got an occupation that we pass in. But you can see it's not doing anything with that yet. Okay, so all it's doing is getting 0 and returning a 0. All right. So I'm going to move on. I'm going to give the max rating a skip, and I'm going to move on to, if you have an occupation of doctor, lawyer, or accountant, you get a rating of 50. Okay, so let's take a doctor. So what do? We read Green Refactor. Okay, so let's write a test. So if we say, oh, that's not the test code. So we say test that doctor gets rating of 50. Yeah? So I'm going to steal this. We want to check against the service, so you need to instantiate a service, which just means to basically put it in memory so it's usable and you can hit it. Okay. And an assert. So the assert statement that I'm writing now is the rule we want to check. Okay, so I want to assert that something is true, or you can assert that something is false. So we say service, and we say calculate credit rating, and I want to put doctor. Yeah? And what does doctor return? 50. Excellent. Okay. So this is a really simple test. What we want to check is that the test actually functions as a test. So I'm going to put 0 for now, so that we can stick with our practice of red, green refactor. Sorry? I can't hear you, sorry? I still can't hear you. Yes, thank you, 2 equal signs. So it would have failed, but yes, thank you very much. A compilation failure is a legit failure. So, good spot. Cool, so now we have 2 tests. What do we expect? 2 passed. Okay, so it's obviously going to pass because I'm still passing 0. Let's change that to 10. Okay, cool. So you can have a look that you've got 1 failure and 1 pass, right? That's what we expect. And it's important that you check that. So a religious TDDer will do what I just did, where I saw it was green, could have moved on with my life, but the code was actually wrong. You want to check that your test is actually testing. So you see the red first, and then you move on. Okay, so we see that the test is testing. We make our statement correct. We still expect failure. Okay, cool. So now I'm going to make the test pass. So the simplest thing I can do is simply just check the occupation. So we say if the occupation is a doctor, then return 50. I'll return that. Yeah? See what that does. Oh, right, Python. Okay, cool. Then return 50. Sorry, I write multiple languages, so they get a bit lost sometimes. I have purposely chosen Python, though, so because it's quite an easy language. So it should be fairly readable when you have a look at it. Okay, cool beans. So we have 2 passing tests. What do we do next? Okay, so lawyer and accountant would be the same. So I'm going to skip those two for now, but they are in part 2. But if you're coding along and you want to give yourself a test to do, then you can implement the lawyer test quickly and the logic. Okay, so the next part is, now if I'm not one of these 3, then I want to return 20. Okay, or at least an amount above 20. Okay, so we're not doing that at the moment. So we want to say test that not a doctor gets a rating of 20. Okay. Assert service. Calls. Just going to say 10 for now. Should fail. Cool. Okay, 20. Okay, cool. So we have a legitimate rule that's failing, so we want to implement the logic for that rule. So we want to say, if you're a doctor, return 50, else return 20. Okay. Is this code readable as a tester? Yeah? Okay. Okay, cool. And that's essentially the idea. So the next part is, if you have a certain number of credit cards, specifically more than 7, then we're going to minus 5 points from you. Okay. So I'm going to write another test. Test that more than 7 cards gets minus 5. Yeah. Okay, so currently the service is only taking in one parameter besides self, which is your occupation. So what do? We need to just add, another one. Okay, and part of this is why some people will tell you that TDD is a design practice rather than a test practice, because I'm essentially driving out what my interface is looking like. Okay, so I'm going to choose to not be a doctor, because I still have to pass an occupation. But I'm going to pass 8 cards. Okay. So someone is not a doctor. Let's go back to the rules. Someone is not a doctor, but we're minusing 5 points. Then it's going to be 50. Okay, but we want to test first. Test the test. Okay. Okay, so there it's telling me what's wrong. The first piece takes 2 positional arguments, but 3 were given. Okay, so that's cool. It's exactly what I want. I know that I'm not passing this, so we say number of credit cards. Okay, cool. Let's see what it tells me now. Okay, and it's telling me that my assert amount is wrong. Cool. So I should still get a similar error on the correct assert statement. Okay, cool. So now we need to implement this code. So we're going to start with 0, and we're going to say, if I'm a doctor, up my total by that. Otherwise by that. And then I need another rule. So I say, if the number of credit cards is less than 7, then I need to minus 5. Okay, minus equals 5. Okay. Still have error. Yeah. Equals 20, should be 15. Yeah, okay, so I'm still getting 20. Oh, thank you. More than 7. Okay, this is why we write tests. Missing one positional argument, number of credit cards. Calculate number of credit cards. Oh, the other tests, yes, you're right. Okay, so this is interesting because you want to keep something as an experiment and you want to keep the other things in control. So we want to make sure that the rule we just implemented is not going to influence our other tests. So we're just going to say we have 1 credit card because if 1 is bigger than 7, it's going to skip that. Okay. Cool. So we actually had a chat about this earlier, where if you have lots and lots of unit tests and you're trying to drive out your interface and you have this lovely massive interface, I just added 1 parameter and I had to change 3 other tests and write a 4th test. This is a very, very tiny app. So you can imagine what might happen if you have lots and lots and lots of unit tests and you want to change things. So we'll keep that in mind. We'll chat about it later. Okay, cool. So I have 4 passing tests. Life is good, and I have the most awesome software on the planet. And that is essentially it. So the idea is you take 1 rule, you implement that 1 rule, and you read Green Refactor over and over and over again systematically. And it's a practice because you saw me do certain things. So I made sure that the test legitimately failed on wrong test criteria. Then it failed on right criteria but no logic. Then it passed on correct logic. That's essentially it, and that's essentially what your dev is doing when they're doing TDD. So if you look at these rules, as testers, how many combinations of things do you think you would test here? Like more than 50? Hands up for like 20. 20 things? 50 things? 100 things? Less than 1,000 things. Okay, so the point I want to make here is that I'm a dev, and what I'm definitely not going to do is go through each and every possible permutation that these things can have. So what I did do is, out of interest, I had a look at all the tests that I wouldn't be writing, which I've now moved somewhere. Is it in here? Yeah. Is it going to work? No. Okay, there's about 50 combinations, and I wouldn't write them. So as I make those rules pass, I don't write those tests because I don't need to. So there is a test where I could be a lawyer and I have more than 7 credit cards and I have a current debt of 8,000 or 12,000 or 3,000. I haven't written any of those. In fact, I would only write one because I only want to check for a lawyer, and I'd maybe write one more for one of these. It wouldn't necessarily be with the lawyer or the doctor or anything like that. So these are a couple of things that your dev might be missing when they do this practice. Now I want to show you here. Okay. So I've got a couple of test cases here, which basically test everything that I need. So how you can read this as is you'll pass in someone's first name, last name, their occupation, the number of credit cards they have, and the rating that we expect. Okay, so this doesn't have the debt part implemented yet. That is all I've written. And that's all I'm going to write until I implement the debt piece, right? So how many are missing? If I had about 50 combinations and I've only written 4, a lot, right? So, but these are valid acceptance tests. Okay. So as a tester, looking at this code and seeing what I've just done, do you think that you would be able to go and implement the rest of the checks? Would it be simple enough? Yeah, I think so. I personally think so. I think that anybody on the team should be able to read most of the code, but especially the tests. And if they're badly written, then you just go back to whoever wrote them and say, I can't read it, you didn't write it well enough. But I think it's really important because, let's move on to the because. So, different people bring different things to their software and to their tests. So you just watched me write some unit tests, and I was doing test-driven design. I have some tests, and that's cool, and it gives me a safety net to go and refactor under, but you certainly can't argue that the tests I've written are good enough to say that my software is great. And it certainly wouldn't pass all the acceptance criteria. So what about QAs? So I found this really useful quote on the internet, which explains that devs are very good at abstraction, and if you tell us half of your problem, we will give you the whole solution. We won't even finish listening to your sentence, because we don't need to, because we think we know what we're doing. Okay, we don't know what we're doing, and we certainly are not very good problem people. So we're very good at coming up with solutions and fixing things, but when it comes to understanding the entire problem, we're probably not, we're half listening to you because our brains are already trying to solve your problem. So this is why I think QAs are not dead, and the practice is really, really, really important. In fact, teams that have more QAs on than devs make a lot of sense to me, especially if those devs can adjust the tests. So what I think QAs bring is upfront acceptance criteria. So a good QA really, really knows the problem, and they really know how to explain what acceptance criteria should be. You can, I mentioned this earlier, you can automate this technically, but it is really difficult So generally, you'll do much bigger tests only at the end because it requires underlying existing code to be there. If you've ever written a Selenium test against a non-existent HTML page, why? That's a really odd thing to do. Your QAs, unlike your devs, can also focus on potential problems, and they can look at different user paths. So what I mean by user paths are different ways that the user can go about your system. They can click different buttons and go back and forth, and many times. And your QAs can also think of really unlikely scenarios. So I've had QAs come to me with the most odd things that I would never, ever, ever have done, because my brain can't think. I'm so busy solutioning, I can't think that far into the problem. I also think that QAs need to be free to be creative and explore. It really makes me sad when a QA has to manually regression test something, because I think that as humans we're much more creative than that. We're not machines. They don't need to run the same regression tests over and over again. And the other thing that a QA can do is, given the ability to automate, when users do discover errors, because errors will get out no matter how resilient your QA is, you don't have to wait for a dev to implement those tests, because the QA can do it. Okay, so things that I think ideally the whole team should do, but both roles, being a QA role and a dev role. I want to chat about test redundancy. So I was on a project recently where the tester and the dev did not have a conversation, and they ended up writing exactly the same tests in 2 automated tools. The dev did theirs in, I think, JUnit, and they wrote some tests, and the tester took SoapUI and wrote the exact same tests, the exact same scenarios in the SoapUI tool. And it was cool in one sense because they were on the same page without talking to each other, so interesting. But it was a waste of work. If they had literally just spent 2 minutes with each other saying, what tests should we have and where should they live, you could have had one person doing those tests and the other one moving on doing something else. Okay, this makes me sad. Okay, test redundancy in a bad way makes me really sad. There is test redundancy in a good way. So what would that be? I'm going to jump out of here for a second. So this guy, he's not in here, has a front end. It's not there. Can I do it from here? Product, templates, yeah. So this guy does have a front end. And what would be useful is one of those acceptance tests that I've written as an integration test, here. That's useful from the front end, one of them. Not all 50 of them. And the reason is because you have to ask yourself, what are you testing for? So are you testing the functional test, the functionality, that when I put a doctor and I have 3 cards that I get 50 out? Or are you testing the mechanism, the non-functional? Can I actually click the button? Does it actually go through to the service? Does it return an answer out? And it's pointless having 50 of these tests that your dev's written, 4, and you've written the others maybe, and 50 of the same on the other side, because they're all testing the same thing, and it slows down your pipeline. The first place to go when you have a really slow pipeline and it's not tool related is your tests, because you probably have redundant tests in your pipeline. Does that make sense? Does anybody have any questions? Yeah. How many tests? It depends on the problem. So this one would probably only have about maybe 10 to 15 if I'm quite diligent. But that'll be from a test-driven design point of view. From an actual test coverage point of view, and I don't mean code coverage, I mean business criteria coverage, you'll have much more. But the point is that you can write those tests in the area that it makes sense to put them in. So if you want to test the algorithm, these PyTest ones that are close to the code are going to be much faster than the Selenium tests that you might have. So when you go and look at the code, you'll find some Selenium tests here where I've written the exact same things, and you can go and compare the speed. I think if I do them from part 2, you'll be able to see them. Let's just go back and have a look. Part 2. Okay, let's see if these actually run. Oh, I have to actually run the back end first. Those are going to fail. Just bear with me for a second. Part 2, product. Okay. So these tests are the exact same tests written in Selenium. What they're doing differently is they're starting up a whole front end, doing the same logic, and then coming back. And we wait. Cool. So that took a lot longer than the other tests I did. Yeah. So you still need them, but when you ask yourself, what are you actually testing? When you know how to read and write tests at a different level, then you'll be able to do all that logic in a much faster running place in your pipeline. Okay. So have a look at different tools and different technologies. I think that anyone who says that testers don't look at the code or don't code is really stupid. So, you know, anyone can code. So not everyone can code well, and that is the truth, but anyone can code. I have seen some horrendous functioning code in my life in bank production systems, and they were just fine. Definitely don't think that you can't do these and that it's the dev's realm. It's definitely not just the dev's realm. Okay, so the bottom line here, and that makes me happy, is the ability that you would then have to put the right tests in the right places. Okay, awesome. And if you remember nothing else, my prayer is that you will set your QAs free from manual testing. That is my mission in life. I have met some really, really, really cool testers. I think really cool testers are born, and you need to treat them well. You don't want to have them sitting in front of a machine, tapping, and doing the same thing day in, day out. It's a waste of their brain. It really, really is. And that's really my talk, but I can take some questions or write some more code. Does anyone have any questions or thoughts? Yes.
How many acceptance criteria would you expect to have those different condition of tests you might want to write? How much acceptance criteria in the user story you would expect as a dev?
How much acceptance criteria in a story?
Yeah.
Okay.
Like all the combination of what you would ideally be testing.
So it's a difficult question because it depends on how large your stories are. Some people write really big stories, which I would disagree with. Those are more like use cases. A story is supposed to be quite small. When I type in this box, it will take my name and I can save my name. That's a story, actually. And the acceptance criteria on that is quite small. It would just be, can I input a name? Can I retrieve the name too? Okay. So it depends. The bigger your story, the more acceptance criteria you're going to have, the longer it's going to take to get that piece of work out.
Yeah, sorry, just to give a comparative picture
Sure.
for the 50 combinations we might be writing.
Yeah.
In this specific example, how many acceptance criteria you might have expected in the story with this given condition?
So for these ones, there were about 50 permutations, given the rules. That doesn't include anything where I'm checking for spelling, checking for negative numbers, anything like that. So it could even be thousands. And that's actually not, I'm not good at that. So I'd actually ask you what you think, because there are things that I won't think of. Once I've solved the problem and written the code, I probably won't actually write any more tests. I might write more tests if I've had a discussion with my tester and they're not able to write more tests. But otherwise, as a dev, once I've designed my interface and I feel like I've got enough combinations, because to me, if I have a doctor with 3 credit cards, it's the same as having a lawyer with 3 credit cards, or 4 credit cards, or 5 credit cards. So I wouldn't necessarily write all those tests to drive my design. Yeah. Cool. Anybody else? Yeah. At the back and then at the front. If they do the same job, why use Selenium tests? Okay. So exactly, that's exactly the point. So you will still want tests at different levels because you want to test for certain things, but you have to ask yourself, what are you testing for? So I would write a logic test that's testing my algorithm much closer to the code, and I would actually write an operational test further away from the code. So what I'm checking with the Selenium test is my website actually functioning? Is it functioning, and is it hitting the service with the algorithm in it, and is it getting the right answer back? So I would at least want 2 or 3 of those to check that, am I hitting the correct algorithm? Is it coming back with the right answer? But I'd want fewer of those because they take a lot longer to run, but you still need some. Yeah. Would I write an integration test or a Selenium test? Mm-hmm. An end-to-end test and a Selenium test are both kinds of integration tests because they're checking the link between your front end and your back end, that they are integrated. A Selenium test would technically be an end-to-end test in this scenario because it's going from the bottom, which is my service with my algorithm, all the way to the top, which is my front end. If I was using a database and I did not hit my database for some reason in that Selenium test, I would personally not call it an end-to-end test because the bottom is actually the database. So it's still a Selenium test because you're running Selenium, but to me that's definitely more an integration-only test than it is an end-to-end test. Yeah.
That was brilliant. And I'd like my testers to say, is
Yeah.
Can we run this at work as well as we
Please do. So yeah, this works as a much better as a workshop. And I've chosen certain technologies on purpose. So I know that a lot of testers are still using Windows, so it runs on Windows. I've chosen Python specifically because it's fairly simple. And I've put answers down so that, because it's very frustrating to get stuck, especially if you're not a tester. So yeah, more than welcome, please use it. Every time that you make a manual tester into an automated tester, my heart will go boom, boom, because it's great. But you're more than welcome to use it. And if you see any issues or you want to make some changes or anything like that, I'm open. So I've never worked as a tester, so I'm more than happy that I don't understand the realm. I think testers' jobs are difficult though. So I would like to make it easier. So anything I can do to make that happen, then please let me know. And I welcome any feedback. So if you think something didn't make sense or it wasn't clear, or you just watched me write some code and you were like, what the hell is she even doing? Please give me a shot. It's not a problem. This light's really bright. Goodness me. Anybody else? Any comments? Any thoughts on whether this would be something you actually use or not? Yes. Mm-hmm. Cool. Yeah. You're most welcome. It's very true. I've met some really brilliant people. I think I've said it at least 3 times now, but I don't think people should be, machines. So I think it's great, and testers are phenomenal. I've had some comments where people have said, why do we have testers anymore? We've got test-driven development, we've got behavior-driven development, we don't need these people. It's not about resource and even technical skill. It's just about logic and how you think. And it has so much more to do with who you are than your skills, actually. I've had testers who don't even know the software very well say, but you didn't think of at least these 5 things that I can just see, and I'm like, how? How do you do that? Like, part of me is like, I really appreciate that because I'm not going to get my ass kicked by a user. But the other side of me is just like, how do you see that? And I don't see that. It's a very frustrating experience. But yeah, no, cool. Thank you very much for your comment. Appreciate that. I think we have a little bit of time. More questions? Yes. Sure. Mm. Yes. Yeah. It's very true. You've made me think of something which is this T-shapedness. So as a dev, people think that I'm a dev because I write code. I'm not a dev because I write code. I'm a dev because I solutionize. And with automation becoming more and more popular, if you have this mindset of you're a dev because you code, my workload just goes like this, and the tester's going, oh, kiff, man, I get to not do anything at work. It's great. Not really. They hate it because they're clever people with brains, right? So it just makes me think coding to me is just a skill that you have, and anyone can do it. And you sound really interesting because if you're really able to do that switch really well, you're like a golden dev. Yeah. Yeah, yeah, and to change that mindset. And the truth is that not everyone can actually do that, and that's okay. Not every dev is going to be really good at writing tests, and not every tester is going to be really good at switching over to code. Especially, I mean, personally, if I was near the end of my career, I wouldn't want to start learning programming. But I can still think about all these combinations, all these different user flows, and I would have had years and years of experience that I can use. So, ooh, are we running late? So, yeah, no, it's good point. Anybody else? No? Cool. Well, thank you very much for coming. And if you need anything, then give me a shout.